answer. Reactant in our chemical reactions, what the substance present that we call reactants, right? So the reactant in which the amount or the mass available is less than the amount required is known as limiting reagent or reactant, right? So what should we understand that in our chemical reaction, okay, those reactants are present in our chemical reactions require some limited amount, right? So the amount of the reactants less than the limited amount, that reactants we call the limiting reagent, right? Understand? Now just I give you the example here. This is the closely vessel, right? So I just close this vessel. Inside this vessel, so very limited amount of the oxygen is present, right? So inside it, we just burn the foil. Okay. So the question is whether this foil will completely burn or not, right? So answer is not. Okay, why? Very limited amount of the oxygen is present. So therefore this oxygen we consider as the limiting reagent because the available amount of the oxygen is less than the amount required by the oxygen, okay, which can burn completely the foil, right? So that is our concept we require to understand. Here is the question. What the question here? 1.0 gram of magnesium. Magnesium, the symbol is Mg. Is burned in a closed vessel. It should be closed because the amount of the oxygen is given here 0.5 gram. If the vessel is open, right? So this may not be 0.5 gram, right? Understand? So it should be the closed vessel. Now question is, what is the limiting reagent? Okay, now let us answer. Let us find out. Write in your copy. How will be the answer? First, we write the balanced chemical equation. Right? Okay, answer is the balanced chemical equation for the reaction is, okay. So what the substance given? That is magnesium. So normally this is solid. Understand? So what is the physical state of the magnesium? Solid. Now it's burned in presence of oxygen, right? What is the physical state of the oxygen? Gas. Right. Now it burns means we heat it. Right. So what will be the product obtained? That is magnesium oxide. Normally this is also solid, right? We write this. Now see, this chemical reaction is balanced or not? I think not balanced, right? See here, how many magnesium here? 1. How many oxygen here? 2. But in the product, only 1 magnesium and 1 oxygen. How will balance? So can we put here 2, right? So oxygen balance, right? So how many magnesium there? 2. Now here also be 2. Okay, you balance this one. And now these numbers, let we convert it, let we express in terms of the mole. How many mole? How many mole? 2 mole, right? Then how many mole of the oxygen here? 1 mole. Don't say 2 because only 1 oxygen molecules here. 1 mole, right? So this is the relation between mole relationship, right? So our question is we are going to find out the limiting reagent. No need to take a serious about this, right? We only find out which one, magnesium or oxygen. Understand? So now here this number of the moles, let we convert it into the mass, right? So here this mole, 1 mole of the magnesium, what we call atomic mass of the magnesium. What is the atomic mass of the magnesium? that is 24 gram. I know it, you please remember, right? 24. How many more here? 2. We multiply by 2, right? So 2 into 24 gram, what will be the mass of this? That is 48 gram. Understand? Then now let we come to the oxygen. So oxygen, how many oxygen atom in oxygen molecule? 2, right? What is the atomic mass of the oxygen? That is 16. 16 multiplied by number of the atoms, that is 2, right? How many more here? 1. So we no need to write it, right? So what is the molecular mass? Here should be molecular because this is the molecule, right? Here is the atom, therefore we call it atomic mass, right? What is the molecular mass of the oxygen? That is 32 gram. Okay. Now we can compare here. If you take 48 gram of the magnesium, right? How much gram of the oxygen required to form the magnesium oxide? 32 gram, right? Understand? Now, so how much magnesium's given here? How much magnesium? Oh, sorry. How much oxygen's given here? 0.5 gram. This is available, right? Then now, how much magnesium is given in the question? That means 1 gram, right? So we can find out either magnesium or oxygen, right? By taking the 1 gram, how much oxygen is required, right? Not this one, right? Okay, by using this 0.05, we can find out how much magnesium required, not this one, right? These are available masses. Okay, so we can find out either magnesium or oxygen. So let me find out the mass of oxygen. Let me find out. You write in your copy on the right side. From the given mass of the magnesium. Okay, so now I write here. Okay, amount or mass. Let me write the mass. It should be very easy to remember. Mass of oxygen available. How much oxygen available? How much? 0.5 gram, right? So now let me find out. Okay, so now how we'll find out? It is simple. Look at, let me write mass of oxygen required to burn, right? Okay, how much magnesium it was written here? How much? 48, no? 48 gram of magnesium. Let me write to burn. To burn, okay, 48 gram of magnesium. How much given here? Oxygen. How much? How much? 32 gram, right? So now we are going to calculate DR4. Let me write it just in long form. Mass of oxygen required to burn. Let me write 1 gram of magnesium. I will write here 32 gram divided by, alright, that is 48 gram multiplied by 1 gram. Okay. Then now what is the our therefore mass of oxygen required to burn? So what is it? Right? 1 gram, no? Yes, let me find out this one. 1 gram is given there. You find out it. 32 divided by 48. Divide. 40, okay? 32 gram divided by 48. Let me do here 32 divided by 48. Since this 48 is more than 32, let me put a 0 point, right? So it's now here 0. How much will it? 6. 6, 4, 6, 8 are 48, right? 4. 6, 4 are 24. 24 plus 4 is 28, right? That. So that means answer will be 0.6 gram, right? See now here from this calculation, how mass of the oxygen required to burn the 1 gram of the manganese, that is 0.6 gram, right? How much oxygen is available here? 0.5, right? This is the available mass, this is the mass required, right? It's more than the available, or it's more than the, okay, required, or it's less than required. No, I mean this is the required amount, right? This is the available amount, right? Okay, this available amount is more than from the required or less than from the required? Less than, no? So that means what is this? This oxygen. This is the limiting reagent. Now here, right? Since the mass of oxygen available, how much available? That is 0.5 gram, is less than, right, mass of oxygen required, that is how much required, 0.6 gram. Therefore, right, what is it? Oxygen is the limiting reagent. This is the answer, right? I remove this one. Yes, this is the answer of this question. And point to remember, see, I write again, Mg plus O2 gives MgO. What we balance here? 2. Here we balance here. How much we write it? 3, no? Is it? Is it 3 or no? 2, no? Here should be 2, no? Right. That means, see, from the calculation we found that the limiting reagent is oxygen, right? So we no need to calculate this magnesium, right? Because this magnesium, obviously this is not limiting reagent, right? Okay, on other hand, when you do calculate this magnesium, right? So this magnesium, if you found as not a limiting reagent, the another one should be limiting reagent. You understand what I said? If this one is limiting reagent, this one is not limiting reagent. If this one is, when you do calculation, if this one is the limiting reagent, this will be the not limiting reagent. That means we are comparing these two, right? If one is limiting, another is not limiting, right? So just we no need to calculate what is the mass of the magnesium required, right? Because since this one is already we know limiting reagent, so we no need to find out the magnesium because this is not limiting reagent. Okay, so this must for today's, right?